In January 2026, at an auto show in Detroit, between the heated tailgates and the minivans with too many cup holders, the United States Army parked a tank. Not a display model, not a Cold War relic dragged out for the kids to climb on. A working machine that almost nobody outside the program had seen, wearing the designation M1E3, rolled onto a carpeted convention floor next to the new pickup trucks. The Army wasn't there for publicity. It was there because it needed help. For nearly half a century, the M1 Abrams has been the heavyweight champion of the modern battlefield, 70 tons. A gas turbine engine borrowed from the aviation world. A gun that fires a dart of depleted uranium fast enough to punch through a concrete wall and keep going. Armor that has absorbed direct hits, which would have turned most of its contemporaries into smoking craters. In the Gulf War, it went undefeated. For 30 years after that, no country on Earth built anything that clearly beat it. And in 2023, the Army canceled its own upgrade program and started over. That's the strange part. Nobody built a better tank. No rival showed up and outshot the Abrams in a fair fight. The champion is being torn down to the frame and rebuilt because of something else entirely. And the answer to what that something is explains why a U.S. Army colonel was standing on an auto show floor in Michigan, asking Ford's aftermarket parts suppliers and the world's largest bulldozer company to please, urgently, help redesign America's main battle tank. To understand what the Army is running from, you have to understand what it was running from the first time. Because the Abrams was born the same way, out of panic. In the late 1960s, America's main battle tank was the M60. It was a solid machine, a second-generation design descended from the M46, M47, and M48 patents. The tanks that had introduced the whole idea of the main battle tank shortly after the Second World War. Before that concept existed, armies fielded separate classes. Light tanks for scouting, mediums like the M4 Sherman to do the everyday work, and heavies like the M26 Pershing rushed into service in 1945 specifically to deal with German Panthers and Tigers. The main battle tank collapsed all three into one vehicle that was supposed to do everything. By the end of the 1960s, the M60 was doing none of it well enough. The reason had a name and a piece of terrain. NATO planners were obsessed with the Fulda Gap, 2 corridors of lowland running between Frankfurt and the border of Hesse, which at the time was the border between West Germany and the East. It was flat, it was open, and it was the most likely route for a Soviet armored thrust into Western Europe. Punch through the Fulda Gap, and you had a fast road to the Rhine crossings, and you cut West Germany in half. The planners ran that fight over and over, and it kept coming out badly. In 1973, the Soviets introduced the T-72, a tank so fundamentally sound that it is still in production today and has served in around 40 countries. Against the M60, it won almost every category that mattered. Its 125mm smoothbore gun fired armor-piercing fin-stabilized discarding sabot rounds, a PFSDS, the long metal darts that kill tanks with pure kinetic energy, at roughly 1,800 meters per second. About 4,000 miles per hour, the M60's 105mm rifled gun managed around 1,500 meters per second. That difference in muzzle velocity translated directly into reach. The T-72 could realistically engage out to about 4,000 meters. The M60's practical envelope was closer to 2,500. In a straight fight across open lowland, that gap means the Soviet tank shoots first. Often it means the Soviet tank shoots first and second. Then there was the shape of the thing. The M60 had a 4-man crew, and one of those 4 was a loader, a human being whose job was to physically pick up a shell and shove it into the breech. A man needs room to swing around. Room means a taller turret. The M60 stood over 10 feet tall. The T-72 had replaced its loader with a mechanical autoloader, and without a body standing in the turret, it came in at a touch over 7. 3 feet doesn't sound like a lot until you're trying to hide behind a fold in the ground. In flat country, the taller tank is the one that gets seen, and the one that gets seen is the one that gets hit. But the thing that genuinely frightened people was the armor. The M60 relied on rolled homogeneous armor and cast steel, conventional plate. The American answer to better Soviet guns had always been more of it, and later variants pushed to around 250 millimeters on the frontal arc. Just over 10 inches. That was a lot of steel. It was not enough steel. Pentagon estimates for the Fulda Gap fight assumed engagement ranges around a kilometer, because that's how far you can see in Central European terrain. At a kilometer, a T-72's sabot round goes through an M60. So does a decent shaped charge heat round, which doesn't care about velocity at all. It burns its way through with a jet of metal formed by an explosive lens. Meanwhile, the Soviets had done something the Americans hadn't. They'd fielded the world's first mass-produced composite armor and put it on the T-72. Instead of thickening the steel, they layered different materials: glass fiber reinforced plastic, ceramics, sandwiched between steel plates. Each layer defeats a different kind of attack. The ceramics shatter and blunt a kinetic penetrator. The plastic layers disrupt the jet from a shaped charge. The result was a glacis that early heat rounds essentially could not defeat, and that shrugged off the M60's armor-piercing ammunition. So the picture was, their tank shoots further, hides better, and is harder to kill. If war came, American armored divisions were going to be destroyed. The first attempt to fix it was a catastrophe. In the late 1960s, the US had teamed up with West Germany on a joint project, MBT-70 in America, Kampfpanzer 70 in Germany, to build one tank both allies would use. Shared cost, shared logistics, shared ammunition. On paper, it was exactly the right idea. In practice, the design teams, led by General Motors and a consortium of German firms, tried to put every advanced technology that existed at the time into a single vehicle all at once. It had an autoloader to drop the height. Fine. It also had high-drop pneumatic suspension that let the driver raise and lower the entire hull, so the tank could kneel down behind cover to about 6.5 feet. It had a 152mm gun launcher that fired conventional ammunition and Shillelagh-guided anti-tank missiles out of the same tube. Its armor was a new space design, an outer plate, then an air gap, then an inner plate, betting that a penetrator would break up on the first layer, tumble through the empty space, and get caught by the second, giving better protection for less weight. And to shorten the vehicle, the designers moved the driver out of the hull and into the turret, in a little counter-rotating capsule that was supposed to keep him facing forward while the turret traversed around him. It did not keep him facing forward, it made him sick. Drivers came out of the MBT-70 nauseated. The autoloader deformed round casings. During demonstrations for the Germans, smoke started pouring out of the hydraulics. The two teams couldn't agree on anything from measurement units to design philosophy, and the budget nearly quadrupled, heading toward a projected unit price of about $1 million per tank at a time when an M60 cost a fraction of that. Senator J. William Fulbright remarked that you'd need a master's degree just to drive the thing. West Germany walked away in 1970 to concentrate on the Leopard 2. The US kept going for another year with a stripped-down version called the XM803, then killed that too in 1971. Which left the Army with nothing, a Soviet tank fleet getting better every year, and a Congress that had just watched it burn hundreds of millions of dollars on a vehicle that made its own drivers vomit. That failure is the reason the Abrams exists in the form it does, because the Army's response wasn't just a new tank. It was a new way of buying tanks. Previously, the government designed the vehicle, and contractors bid for the right to build it. Now the Army issued a requirement and let industry submit competing designs, with a hard ceiling written into the request for proposals. No more than $507,790 per tank in early 1970s dollars. Roughly $4 million today. This was designed to cost. The price wasn't an outcome. It was a specification, exactly like the armor thickness. General Creighton Abrams, then Army Chief of Staff and the man the tank would eventually be named after, set the weight target at 58 tons. Same ballpark as the M60. No weight spiral, no repeat of MBT-70. And here the Americans got a gift from the British. Researchers at the Royal Armament Research and Development Establishment had developed their own composite armor, known as Burlington, and later universally as Chobham after the site where it was developed. Britain shared it. That single transfer of technology is what made the whole equation work, because it broke the link between protection and weight. The XM1 could carry a frontal array around 2 feet thick, more than double the M60's maximum, and still come in at roughly the same tonnage because most of that 2 feet wasn't steel. The tactical requirement that fell out of it was blunt. The tank had to survive a hit from any Soviet gun at 800 meters. Not a glancing hit at long range, a hit at knife-fighting distance. Chrysler and General Motors both submitted prototypes in 1976. GM played it straight. Their design used a conventional 1,500 horsepower diesel, closely related to the MBT-70's power plant. Proven, efficient, understood. Chrysler did something odd. They put a turboshaft gas turbine in theirs. A turbine is an aircraft engine. It sucks in air, compresses it, sprays fuel in, ignites the mixture, and blasts the hot gas through a set of turbine blades. In a jet, the exhaust itself pushes the aircraft forward. In a turboshaft, the blades spin a shaft, hence the name, and that shaft drives a transmission, which drives the tracks. Chrysler weren't the first to think of it. The Soviets fielded the turbine-powered T-80 that same year. The Swedes had beaten everyone with the Stridsvagn 103, designed in the 1950s with a gas turbine alongside a diesel. But Chrysler had a genuine institutional obsession with turbines. Rover in Britain had built the first gas turbine car, the Jet One, in 1950. Chrysler became the first American company to take it seriously, and in 1963 they built a fleet of Chrysler turbine cars and handed them out to the public. 200 ordinary drivers put over 1 million miles on them. Then Chrysler looked at the fuel bills, concluded that turbines made no sense whatsoever in a family sedan, and destroyed almost all of the cars. 9 survive. Jay Leno owns one. So Chrysler liked turbines. The Army did not. When they tested the Chrysler M1 prototype, its fuel consumption came out at 3.8 gallons per mile. Not miles per gallon, gallons per mile. The prototype could travel less than 1,400 feet on a gallon of fuel. On top of that, evaluators rated Chrysler's armor protection, fire control, and turret stabilization as inferior to GM's, and Chrysler wanted more money. In 1976, the Army made its decision. General Motors had won. All that remained was sign-off from the Secretary of Defense, Donald Rumsfeld. And then the decision didn't happen. The Deputy Secretary of Defense at the time was William P. Clements, Jr., who chaired the Defense Systems Acquisition Review Council, the body that reviews major programs before they proceed. Clements, apparently a great admirer of gas turbine technology, persuaded Rumsfeld to hold off for several months and to add a new requirement to the XM1 competition. The winning tank would have a gas turbine engine. The Army objected. The Army lost. GM did what it was told and integrated a turbine into a revised prototype, which pushed their price up. Chrysler, who already had a turbine, spent those same 4 months cutting costs and brought their bid down. In November 1976, the Department of Defense awarded the contract to Chrysler. Historians have been skeptical about the depth of Clements's engineering enthusiasm ever since, because of what else was happening in 1976. Chrysler was dying. Its car division was bleeding money badly enough that the company would need a federal loan guarantee within 3 years. Military work made up something like 5% of Chrysler's income against roughly 1% of GM's, meaning the tank contract mattered enormously to one bidder and barely at all to the other. Chrysler lobbied the Pentagon hard, argued that losing the XM1 would push the company into bankruptcy and take a chunk of the American economy with it, and threatened a formal protest if GM won, which is why some people call the XM1 award the first bailout of the American auto industry. There is a decent argument that America's greatest tank exists because a car company needed the money. The first production vehicles came out of the Detroit Arsenal tank plant in 1978. Low-rate production started the following year, and the tank entered service in 1980 as the M1 Abrams. In an ending that is either ironic or simply how defense works, General Dynamics bought Chrysler's defense division in 1982, after about 1,000 tanks had been built, and moved production to Lima, Ohio. In total, 3,273 of the original M1s were produced. The tank weighed 60 tons and stood exactly 8 feet tall, a full 2.5 feet shorter than the M60 despite still carrying a human loader. 4 crew: commander, gunner, loader, driver. Main armament was a 105mm rifled gun-firing ammunition derived from the British Royal Ordnance L7, the same caliber as the M60, which disappointed a lot of people at the time. Supported by a .50 caliber and two 7.62mm machine guns, the Chobham was the headline. The exact recipe is still classified, but it's understood to combine ceramics, plastics, laminates, and metal alloys in layered arrays, and it is extraordinarily good against shaped charges as well as effective against kinetic penetrators. What that means in practice showed up in Basra in 2003, when a British Challenger 2, also Chobham protected, got stuck in a ditch and was attacked for hours with RPGs and recoilless rifles. The crew survived. The tank survived. Reinforcements eventually pulled it out. But the feature that actually kept American crews alive was something quieter, and the original design got it right in a way almost nobody else did. Tank ammunition is the most dangerous thing inside a tank. A penetrator that gets through the armor doesn't need to hit a crewman to kill everyone. It just needs to hit the ammunition. Soviet designs stored their rounds in a carousel in the hull floor, underneath the crew, because that's what an autoloader needs. When a T-72 is penetrated and the carousel goes up, the entire turret is thrown off the vehicle. There are hundreds of photographs of it from Ukraine. Nobody gets out. The M1 stored its main gun rounds in a compartment at the rear of the turret bustle, behind a sliding armored door, with blowout panels in the roof above them. If the ammunition ignites, the door holds and the panels give way, and the entire force of the explosion vents upward into the sky instead of downward into the crew. That's the sort of decision that never makes a spec sheet. It costs turret volume, it costs weight, and it requires a human loader to keep opening and closing a heavy blast door in the middle of a firefight. It has also, repeatedly, been the difference between a destroyed tank and a dead crew. The turbine, meanwhile, turned out to be less stupid than the Army had feared. The AGT-1500, originally a Lycoming design, later built by Honeywell, makes 1,500 horsepower from a package considerably smaller and lighter than a diesel of the same output. It delivers torque across a wide range, which is why a 60-ton vehicle accelerates the way the Abrams does. It starts in cold weather that would defeat a diesel. It has far fewer moving parts. And because a turbine burns essentially anything that combusts in a continuous flame, the M1 will run on jet fuel, diesel, kerosene, or gasoline without modification, which matters enormously when you're fighting in a coalition and the only fuel truck available is somebody else's. Chrysler had demonstrated the point during the turbine car days by having the president of Mexico fill one up with tequila and later running one in Paris on Chanel No. 5. Battlefields are not generally awash in perfume, but an army that can refuel from an air base, a captured depot, or a civilian filling station has options that an army with one fuel type does not. The other advantage nobody predicted was acoustic. A diesel produces a deep rumble that carries for kilometers across open ground. A turbine produces a high-pitched whine, deafening if you're standing beside it, but high frequencies fade fast in air. Iraqi troops in 1991 reportedly called the Abrams "whispering death" because the noise didn't arrive before the tank did. And the costs? It drank fuel at a rate that horrified every logistician who looked at it, roughly 2 to 3 gallons per mile depending on terrain, and 10 to 15 gallons an hour just sitting still with the engine idling to run the electronics. It also produced a large, hot exhaust plume, which is a gift to anyone with a thermal imager. The Army accepted all of that because in exchange it got the best tank in the world and because it had total air superiority. If you own the sky, your supply convoys are safe. And if your supply convoys are safe, you can run whatever fuel bill you like. Remember that trade. It's the whole story. The tank that made the Abrams legendary wasn't the original. In 1986, production shifted to the M1A1, which swapped the 105mm for the 120mm M256 smoothbore, a German Rheinmetall design built under license, and added depleted uranium mesh to the armor array. Depleted uranium is roughly 2.5 times denser than steel, which is exactly what you want both in armor and in a penetrator. Then came 1991, and the M1A1 met the tank it had been designed to fight. Two caveats are necessary, and the second one matters more than people think. First, the Iraqi T-72s were export models with downgraded armor and, critically, without thermal sights. Second, they were firing older steel-cored ammunition rather than the modern penetrators the Soviets kept for themselves. But the decisive American advantage wasn't the armor or even the gun. It was the fire control. The M1A1 had a thermal imaging sight, a laser rangefinder, a ballistic computer, and a fully stabilized gun, which means the gunner sees heat, not light. Smoke doesn't stop him. Darkness doesn't stop him. Sandstorms don't stop him. He laces the target. The computer takes the range, the crosswind, the ammunition type, the barrel wear, and the tank's own motion, and puts the gun where it needs to be. And the stabilization holds the aim point steady while the tank is moving at speed over broken ground. An Iraqi crew, in the same weather, was looking through optical sights at a wall of blowing sand and burning oil smoke. The result was the most one-sided armored campaign in history. The Army credits Abrams crews with destroying around 1,270 Iraqi tanks during Desert Storm. At 73 Easting, at Medina Ridge, at Norfolk, American tanks opened fire at over 3,000 meters, while the Iraqi effective range was around 1,800. The Iraqis were being killed by vehicles they could not see, from a distance they could not reach. Not a single Abrams was lost to Iraqi tank fire. The ones the US did lose were overwhelmingly hit by other Americans in bad visibility with American ammunition. That detail says more about the tank than the kill ratio does. In 4 days of high-intensity armored warfare, the only thing that reliably killed an Abrams was another Abrams. And there's the incident that became the legend. An M1A1 bogged in mud, ambushed by 3 T-72s at around 400 meters. It took heat rounds and 125mm sabot at point-blank range. Nothing got through. The crew, stuck and unable to maneuver, destroyed all 3. That was the peak. The erosion started almost immediately after. In 2003, Abrams crews again dismantled Iraqi armor without difficulty, and then discovered that the war didn't end when the tanks did. In cities, an Abrams is a 60-ton vehicle with a thin roof, a thin belly, and limited gun depression, moving through streets where every window is a firing position. Roadside bombs and shaped charge IEDs killed American tanks that no T-72 could touch. Houthi forces in Yemen later destroyed Saudi-operated Abrams with modern anti-tank guided missiles. Again, export models without the depleted uranium package, which matters, but the pattern was clear enough. Then Ukraine. The United States gave Ukraine 31 M1A1s starting in September 2023. Of those, roughly 22 have been destroyed or damaged and abandoned. One was captured and put on display in Moscow. The tempting explanation is that Russian tanks beat it. That explanation is wrong. Russia is fielding T-80S and T-90S and has lost them by the dozen. Tank versus tank engagements in Ukraine are rare, genuinely rare to the point where many crews on both sides have never fought one. What killed the Abrams in Ukraine was a first-person view drone costing a few $100s, flown by an operator sitting in a tree line 2 kilometers away, dropped onto the engine deck or the turret roof where the armor is thinnest. And guided artillery, cued by a surveillance drone that saw the tank an hour before it moved. Which brings the story back to the trade the Army made in 1976. The turbine's fuel appetite was acceptable because rear areas were safe. Rear areas were safe because America owned the sky. Nobody owns the sky anymore, not in the way that word used to mean. A cheap quadcopter can loiter over a supply route and call in fire on a fuel convoy, and the convoy is what makes the tank work. Without it, the toughest tank ever built stops moving in a couple of 100 miles. That's the actual defeat. Not armor versus gun, fuel truck versus drone. Meanwhile, the Abrams had been getting heavier for 40 years, because every new threat was answered by bolting something onto a design that was fundamentally fixed in 1976. More armor. Reactive armor tiles for urban fighting. An auxiliary power unit added on a later variant, so the tank could run its electronics without idling the turbine. A genuine improvement, and also more weight. Trophy Active Protection, the Israeli system that shoots down incoming missiles. All of it necessary. All of it heavy. In 2023, the Army looked at the next planned upgrade, SEPV4, which would have added better sensors, networking, and threat detection, and realized the tank was heading past 80 tons. At that weight, you are not crossing most bridges in Eastern Europe. You are not fitting comfortably on standard transport. And your fuel consumption gets worse in exactly the war where fuel is the vulnerability. So the Army canceled it, not delayed. Canceled, and announced that instead of upgrading the Abrams again, it would strip the design to its bones and re-engineer it, the way it had in 1976. And then it went further and re-engineered how the tank gets built. Normally, the Army hands a multi-billion-dollar contract to one prime contractor, General Dynamics Land Systems in this case, and waits. This time, the Program Executive Office for Ground Combat Systems decided to act as its own general contractor, breaking the vehicle into pieces and contracting them out to a range of companies, with heavy emphasis on the American commercial auto industry. Geographically, this was almost too convenient. That office sits at the Detroit Arsenal in Warren, Michigan, the same site that housed the plant where Chrysler built the first M1s before General Dynamics bought the division. The team redesigning the Abrams works where the Abrams was born, in the middle of the largest concentration of automotive engineering talent in the country. GDLS remains the backbone, with an engineering contract for overall program support and for supplying older hulls to be converted. But the pieces are being spread around. Roush Performance, founded in 1995 by Jack Roush and best known for high-performance aftermarket parts for Mustangs and F-150s, was brought in to design the crew compartment. For 4 decades, the inside of an Abrams meant cramped mechanical chaos, hydraulic lines, hard corners, analog gauges. What Roush has built is a digital crew capsule with controls from Fanatec, a company that makes high-end sim racing wheels, feeding into a computing core with a 360-degree camera network that lets the crew effectively see through the armor using augmented reality headsets. The seats are custom Recaros, chosen partly to absorb blast shock through the floor. The important change isn't the seats, it's that there are only 3 of them. Commander, gunner, driver, sitting side by side in the front of the hull. Nobody in the turret at all. The human loader is gone, replaced by an autoloader, and once there's no one in the turret, you no longer have to armor the turret to protect a person. That single decision is the main reason the M1 E3 comes in around 60 tons instead of 80. 20 tons, removed by taking one man out of the vehicle. It is not a free trade, and it's worth being honest about the cost. A good human loader gets around into the breach in under 5 seconds, can clear a jam with his hands, and can change his mind mid-cycle when the commander suddenly wants a different round. Autoloaders are consistent but inflexible, and when they break in ways a crew cannot fix in the field. The other cost is quieter. A tank crew doesn't just fight. It replaces track pads, refuels, pulls maintenance, pulls guard duty at night. 4 men splitting, that is hard. 3 men splitting it is harder, and after 2 days of combat, exhaustion kills crews as reliably as ammunition does. The Army has decided the 20 tons are worth it. Ukraine is the reason. The most radical change is under the deck. Caterpillar, the construction equipment company, is providing the power plant, and the gas turbine that defined the Abrams for 45 years is gone. What replaces it isn't a new engine at all. It's a commercial off-the-shelf Caterpillar C13D heavy-duty inline-six turbo diesel producing around 1,000 horsepower, paired with a hybrid electric transmission. On raw numbers, that's a downgrade, 1,500 horsepower to 1,000. But horsepower means nothing on its own. What matters is horsepower per ton, and the M1 E3 has shed 20 of those. And the hybrid element allows the system to dump stored electrical power into the drive for short bursts, which is what a tank actually needs, not sustained top speed, but the ability to lunge from cover to cover. The advantages stack up fast. A diesel is inherently more efficient than a turbine, and hybridizing it improves that further. Program targets have aimed at cutting fuel consumption dramatically compared with the turbine. Hybrid demonstrator work has claimed reductions in the region of half. Having the fuel bill halves the convoy, and the convoy is the thing the drones are hunting. The tank can also run its entire electronics suite off the battery with the engine completely shut down. No idling, no auxiliary power unit burning fuel, nothing. At low speed, on battery alone, it is nearly silent. Not turbine quiet, silent. An M1 E3 can sit in ambush making no noise at all, and then move, slowly but move, across terrain on electric power without ever starting the diesel. With the diesel off, its thermal signature drops as well. That is aimed directly at the thermal cameras hanging off every drone over Ukraine. A cold, silent tank is a tank the operator's software doesn't flag. And there's a logistics argument that has nothing to do with combat. The AGT-1500 is a specialized military turbine that has to go back to a depot for serious work. The C13D is a commercial engine from a company with service coverage across most of the planet, tens of thousands of suppliers, and manufacturing on multiple continents. If an M1 E3 throws an engine in Poland, the odds are decent that the parts and someone who has rebuilt one before are within a day's drive. Up top, the gun is the one thing that hasn't changed. The M1 E3 carries the same 120mm M256 smoothbore that has been on the Abrams since the M1 A1. And that's deliberate because the ammunition is where the improvement lives. It still fires depleted uranium sabot for killing armor. But its signature round is the XM1147 Advanced Multipurpose. As the autoloader chambers it, a data link physically programs the fuse in the milliseconds before firing. Against a light vehicle, the crew sets it to detonate on impact. Against a bunker, they set a delay so it punches through the concrete and explodes inside. Against infantry in the open, they set airburst, and it detonates overhead and showers them with fragments. One round replaces 4 separate types, which means the ammunition compartment holds more useful options in less space. And that matters a great deal when your autoloader has a fixed number of slots. With nobody in the turret, nobody is standing in a hatch behind a machine gun. The coaxial 7.62mm is now operated remotely from inside the hull, through a remote weapon station that can alternatively mount a 40mm Mark 19 grenade launcher or a Javelin missile launcher. And the turret carries an EchoGuard radar system tracking incoming threats, loitering drones, guided missiles, RPGs, feeding an active protection system. When the radar sees something coming, the fire control computes the trajectory in milliseconds and picks a response: a soft kill, jamming the guidance, or a hard kill, slewing a launcher and firing a tight pattern of projectiles into the incoming round. Essentially a shotgun blast aimed by computer at something moving several hundred meters per second, which is only possible because of the last piece and the one with the longest consequences. Every previous Abrams was a closed system. If the Army wanted to add a sensor or change the software, it went back to the manufacturer, waited, and paid. For 40 years, the price of that 1976 contract wasn't the tank. It was that only one company could ever modify it. Every capability the Army wanted arrived on the vendor's schedule, at the vendor's price. The M1 E3 uses a government-owned modular open systems architecture. That phrase is doing a lot of work, but what it means is simple. The tank has a standardized digital backbone that third-party hardware and software can plug into, and the Army owns the standard. If a small company builds a better drone jammer, the Army buys it and installs it. No renegotiation, no waiting. That's not an engineering decision. That's the Army trying to escape a procurement trap it walked into during the Ford administration. Sitting on that backbone is the part that gets called the tank's brain. The Army wants what it describes as a cognitive vehicle, AI acting as an active participant rather than a set of passive instruments. In practice, its primary job is threat triage. A crew of 3, buttoned up, looking at camera feeds, cannot process dozens of simultaneous radar and optical contacts. The system's job is to decide which of them is about to kill them and say so first. The Army is also using generative AI tools internally to write back-end code and run simulated testing, which is a large part of how it hopes to integrate new hardware in months instead of years. Whether a 4th crew member made of software is an asset or a liability is a question the Army is going to answer the expensive way. The vehicle unveiled in Detroit isn't a prototype. It's a pre-prototype, a baseline built to test the more radical ideas before anyone commits to a final configuration. Soldier testing is slated for summer 2026, with a fielded design expected within roughly 2 to 3 years. No basing has been announced, but the intent isn't subtle. The M1 E3 is aimed at Europe. The weight reduction alone means it can cross around 30% more bridges in countries like Poland than the current variant can, and in Eastern Europe, where a river crossing can decide a campaign. Bridge classification is not a footnote. It's whether your armor arrives. It also will not arrive uncontested. Everyone watched Ukraine, and everyone drew conclusions. Germany and France are jointly developing the main ground combat system to replace the Leopard 2 and the Leclerc, with 130mm and 140mm cannons under active test, a straightforward bet that the answer to better armor is a bigger gun. It's a reasonable bet. It's also bogged down in political infighting between the French and German defense industries, in a way that anyone familiar with MBT-70 will find grimly familiar. The M1 E3 will almost certainly field first. Russia's answer isn't the T-72 or the T-90, it's the T-14 Armata, unveiled over a decade ago. The first tank in the world with a genuinely unmanned turret, and the crew in an armored capsule in the hull. Conceptually, it is the same tank as the M1 E3, and Russia got there first. But it has been strangled by an inability to procure the microelectronics it needs at scale. It exists in small numbers, has never been mass-produced, and has not been meaningfully committed to the war Russia is currently fighting. On paper, it's a serious rival. On paper is where it has stayed. The real competitor showed up in Beijing in September 2025. The Chinese Type 100 is not a heavier, tougher Abrams. It's an argument that heavy, tough tanks are the wrong answer. It weighs under 40 tons, carries a crew of 2, and mounts a 105mm gun. By every traditional measure, an M1 E3 would destroy it in a straight fight. The Type 100 is designed never to have that fight. It's built for engagement beyond visual range. It carries a vertical launch system for drones. It can sit behind a ridge or a tree line and put a swarm into the air, some for reconnaissance, some to dive onto enemy vehicles from above, where every tank on Earth is thinnest. It's designed to operate paired with a support vehicle carrying a heavy reconnaissance drone, linked back to the tank, feeding video to the crew through augmented reality headsets, not unlike the M1 E3's. It is less a tank than a mobile command node for a hive of expendable machines. And that is the honest uncertainty at the heart of all this. China's design says the vehicle is now a launch platform, and the killing is done by cheap things in the air. America's design says the vehicle still has to survive contact, still has to hold ground, and the answer is to make it lighter, quieter, cheaper to feed, and smart enough to shoot down what's coming. The Chinese approach is a much bigger gamble, and if it's wrong, a 40-ton medium tank with a 105mm gun is going to have a very short afternoon. If it's right, the M1 E3 is a beautifully optimized answer to the previous war. Nobody knows. The last time anybody had good data on what wins a tank battle was 1991, and the world that produced that data no longer exists. What we do know is how the champion got here. The Abrams was never beaten by a better tank. It won its only real war so completely that the loss ratio doesn't look like a battle, and in the decades since, no enemy tank has ever destroyed one in a fair engagement. It was beaten by arithmetic, by fuel it couldn't get, by weight it couldn't carry across a bridge, by a few $100s of aircraft flown by a conscript with a video screen, and by a contract written in 1976 that made it expensive to change. Which is why, in January 2026, a U.S. Army colonel drove the future of American armor onto a carpeted floor in Detroit and parked it between the pickup trucks. The tank that was born there because a car company needed a bailout has come home half a century later because the Army needs what car companies are good at: building things cheaply, in volume, out of parts you can get anywhere. The heavyweight champion didn't lose its title in a fight. It lost it on the scales. So, the Abrams betting on survivability, or the Type 100 betting on drones. Which one do you think gets the next war right? Drop your pick in the comments. And if you enjoyed this one, hit like and subscribe to Vector 1.